Yes, guys, welcome to our channel once again, where we learn all about mathematics. Here we have a problem sent to me by one of us. Prove by mathematical induction that the sum from r equal to 1 to n of 2 plus 3r is equal to n over 2 of 3n plus 7, for n being the set of positive integers. I want to bring one thing to our notice here, that this is mathematical induction and we have to use the principles of mathematical induction, which says if the statement to be proven is true for some values, say n equal to 1, for example, then we assume that this statement to be proven is true for a certain p or a certain k being an integer. We use that assumption and prove that the statement is true for some p plus 1 or for some k plus 1. Then the statement is true for all n in Z. So these are the steps we are going to take. So the first thing is, we'll say, let the statement to be proven. Let Sn be the statement, the sum from r equal to 1 to n of 2 plus 3r is equal to n over 2 times 3n plus 7. Let this be Sn. Now, when n is equal to 1, what happens to the left hand side and what happens to the right hand side? When n is equal to 1, S1 is such that the left hand side is 5. If we substitute 1 in place of r here, we are going to have 2 plus 3. And remember that r is summing from 1 to n. Now, if we substitute 1 in place of n on the right hand side, the right hand side will also be equal to 5. So Sn is true where n is equal to 1, because if we substitute 5 on the left hand side, on the right hand side we are going to have 1 over 2 times 10, which is 5. So you see that Sn is true for n equal to 1. And remember that n equal to 1 is an integer. Since we have seen that Sn is true for n equal to 1, let us assume that Sn, assume Sn is true. Assume Sn is true for n equal to k. That is, the sum from r equal to 1 to k of 2 plus 3r is equal to k over 2 times 3k plus 7, comma, k being an integer. Now, this is our assumption. We now use this assumption to prove that Sn to be true for n equal to k plus 1. That is, you know that since this is a sum, sk plus 1 will be the same as sk plus the k plus 1th term. And this will be equal to, what is your sk? Your sk is k over 2 times 3k plus 7 plus sk plus 1 will be 2 plus 3 times k plus 1. So we simplify this and see that we will arrive and see that we will arrive here. And how do you know that you have arrived? That's always the problem with many candidates or many students. How do you know that you have really arrived? When you simplify, how do you know that you have arrived? Now, since we want to prove that Sn is true for n equals to k plus 1, if we arrive in the place of n, we put k plus 1 over 2 times 3 times in the place of n, we have k plus 1 plus 7. If we arrive here, it means that we have shown that sk plus 1 holds. Now, we go back. We are solving now. So if we simplify this, we are going to have k over 2 times 3k plus 7 plus 2 plus 3k plus 3. I open the bracket up here. Now, k over 2 times 3k plus 7 plus 3k plus 5. We look for LCM and simplify. We'll have k times 3k plus 7 plus 2 times 3k plus 5. All this divided by 2. And this will give us 3k squared plus 7k plus 6k plus 10, because this 5 here, divided by 2. We go now to 3k squared plus 13k plus 10 over 2. The numerator is a quadratic, and this quadratic is factorizable. And from the knowledge of factorization of quadratic expression, when we factorize this, we are going to have k plus 1 times 3k plus 10 over 2, which can be written as k plus 1 over 2, k plus 1 over 2 times 3k plus 3 plus 7. I'm bringing in 7 because I want to put it in this form. So we now go back. This is k plus 1 over 2 times, factorize 3 inside here, you have 3 times k plus 1 plus 7. You see that sk plus 1 holds because this 1 is your n, this 1 is your n. You see? So, conclusion, we now say, since Sn is true for n equal to 1, n equal to k, and n equal to k plus 1, comma, Sn is true for all n in Z plus. Thank you, guys. It's been another moment together. Remember to subscribe and put on the notification bell so that whenever we put up a new video, you are going to be notified about it. Do well to kindly like, share, and comment. And remember, it's from your comments that we improve on how to serve you better. Catch you some other time.